Hello students. In this particular video, we'll be looking at the solutions of the assignment that I gave you on simultaneous equation, right? So this is the first one. I've actually given you two assignments on this. The first one over here is basically just solving a couple of simultaneous equation algebraically. So you're going to use the concepts of algebra to help you to solve this type of questions, right? So so let's begin and let's see if you have gotten them right as you go through the solution. Now, of course, as usual, if you have gotten it wrong, well, perform your corrections and we learn from corrections. Okay, so let's do it properly and let's present our work in a very systematic manner, right? This is really is good for you. Okay, so the first question you're told to do is this particular question, question 2E, right? You're supposed to use the elimination method to solve this pair of simultaneous equation. So the first one, 7x minus 3y equals to 13. Just write it down. We name this equation 1. Second one, 2x minus y equals to 3. And we name this equation 2. Okay. So let's observe this. And let's see what is the best way that we can eliminate either the unknown x or the unknown y, okay, the variable. So over here, we have 7x and 7x and 2x over here. So in order to make them have the common coefficient, I do need to multiply 2 to the first equation and multiply 7 to the second equation. It can still be done, okay, but there are more steps to it. Okay, it is actually easier in this particular example to just multiply the second equation by 3. By doing that, okay, we will have negative 3y for equation 1, and then equation 2, after that, we will get negative 3y, and then we can name that equation 3. Okay, and that's exactly what we're going to do. So you can see here, okay, I'm going to put 3 times equation 2, and then so we'll do this. 2x times 3 give us 6x, negative y times 3 become negative 3y, 3 times 3 becomes 9. So this equation over here, I'm just going to call it equation 3. Now that we have that, when we compare equation 1 and equation 3, we find that there's a negative 3y here and there's a negative 3y over here. So if we take one equation, subtract the other, negative 3y subtract negative 3y, the variable y is eliminated. Okay, so that's what we're going to do. So in the next slide, you can see I've written here equation 1 minus equation 3. So how do I get this straight away? Well, let's take a look. 7x minus 6x give us x, right? Now, we have already talked about negative 3y minus negative 3y gives us 0, so the y is eliminated. So 13 minus 9 gives us 4. And that's how we very quickly manage to obtain that x is equals to 4 using elimination method. And of course, don't forget, after we found our x, let's not neglect our y, right? So we need to substitute x equals to 4 into either one of the earlier equations. So in this case, I can put it into equation 2. That gives us 2x, right? X is now 4 minus y equals to 3. And when you simplify this, we get y equals to 5. Finally, good habit, rewrite the solution again properly. Therefore, x equals to 4 and y equals to 5. Okay. Now, let's move on to the next question. The next question is this question 4C. The requirement this time round is for us to use the substitution method. So the substitution method is slightly different, of course. We do not need to match up the coefficient of either the x or y, but rather we make use of the concept of change of subject, right? We choose one of the equation, change the subject to one of the variable, and then we substitute. So let's see how it works. The first one, we have 2x minus 7y equals to 5. Same thing, let's call this equation 1. 3x plus y equals to negative 4. Let's call this equation 2. So choosing which one, we can choose equation 1 or equation 2 to start with. But since the coefficient of y over here in equation 2 is just 1, it is actually a lot more convenient to change the subject in this case. So I'm going to start from 2. I'm going to rearrange this and we will have y equals to negative 4 minus 3x, right? And we're going to call this equation 3. Now, once we have this change of subject version of the equation, we're going to substitute it into the other equation which we have not used. So substitute equation 3 into equation 1. So we have 2x minus 7y, but substitute the y with this expression equals to 5, right? Simplify it by expanding. So 2x plus 28 plus 21x equals to 5. Take note, is this negative 7 times negative 4. That's why it's a plus 28 here. Same thing is negative 7 times negative 3x. Therefore, it's a plus 21x over here. Okay, continue to simplify. We will have 23x equals to negative 23, giving us the solution x equals to negative 1. Now, once again, I'd like to remind you, do not forget to find y after we have found our x. So substitute x equals to negative 1 back into either one of the earlier equation. But in this case, substituting back into equation 3 makes the most sense because y is already the subject, right? So we do not need to do any manipulation if we do that. So substitute into equation 3, y equals to negative 4 minus 3x, but this time around, replace the x with negative 1. Simplifying this, we have y equals to negative 1. Therefore, this particular question, the solution is x equals to negative 1, y equals to negative 1. Okay, all good. I hope you're getting this. Right, the next question that I ask you to try is this question 7a. So let's take a look. Now, 7a, this time round, we increase the complexity of the question a little by introducing fraction. But we have dealt with fractions before. Okay, you have actually learned it in last year's syllabus. So most of you who are comfortable with algebra, this should not be an issue, right? And we are supposed to use elimination method. So let's see what we can do, right? So the first thing we're going to do is to take the algebraic fraction, rearrange it into a linear form, okay, where there is no fraction. So how do we do that? Okay, in this case we can employ a technique known as the cross multiplication. That is the denominator actually multiplied across the equation. What's actually happening is mathematically what's actually happening is we actually multiply by the multiple of the denominator. So what it means is that from here, if you take a look, equation 1, we have x plus 1 over y plus 2 equals to 3 over 4, right? Equation 1. To get the equation 3, which is the form that we want, okay, I'm actually multiplying 4y plus 8. Where do I get 4y plus 8? Actually, it's 4 times y plus 2, the multiple of the two denominators. But in terms of writing out the solution, to speed things up, we can actually just cross multiply. Okay, so 4 goes up, y plus 2 goes up here. And that's how we get this from equation 1. We have 4 times x plus 1. Okay, and then equals to 3 times y plus 2. So the denominators have went up to the opposite side. Expanding it, 4x plus 4 equals to 3y plus 6. And then we want to write it in this form, which we are familiar with. Okay, 4x minus 3y equals to 2, right? Just rearrange it and we have this. So we're going to call this equation 3. Then from equation 2, we're going to apply the same technique. So cross multiply, 5 times the numerator here. So 5 is the denominator on the opposite side. So 5 times x minus 2, and then 3 times y minus 1. Expand. Okay, expand carefully. Simplify. We have 5x minus 3y equals to 7. Equation 4. After this, we observe equation 3 and equation 4. And we can see that the coefficient of y is the same. Both the coefficient is negative 3. Therefore, we can just take either equation 3 minus equation 4 or equation 4 minus equation 3. It doesn't matter. You will get the same solution if you do it properly, right? So in this case, we take equation 4 minus equation 3. So we have 5x minus 4x. We have x. The negative 3y is eliminated. And then 7 minus 2 gives us 5. So we have the solution for x, right? And then we need to get y. So substitute into any of the earlier equation. So in this case, we'll go into equation 3, right? Why not, right? So substitute x equals to 5 into equation 3. We have 4x. Okay, replace the x with what? 5 minus 3y equals to 2. Simplify, we get y equals to 6. Finally, good habit, write down, therefore, x equals to 5, y equals 6 as the final statement over here. Okay, so that's question 7. Okay, for the next question, we are back to substitution method, right? So the question actually wants us to use substitution method, and compared with the earlier example where we use substitution method, we increase the complexity a little bit by introducing some fractions. But as long as we are careful with our algebraic manipulation, we are not worried about fractions, right? So same process, right? So what we're going to do, we're going to start from equation 1. Okay, we're going to rearrange it. So y, and then we minus 2 minus x over 5. So they go to the other side of the equation in this way. So y equals to negative x over 5 minus 2. And we're going to call this equation 3. So we change the subject first. Okay, so just to refresh your memory again, for elimination method, we want the coefficient to line up, okay, to be the common multiple. And for substitution method, we actually use the concept of change of subject. Okay, so from equation 3 over here, now we substitute equation 3 into equation 2 because we start from 1. So to get 3, we need to go back to 2 in order to complete the cycle, right? So we have x over 3 minus y, right? Replace the y, substitute it with this expression from equation 3, minus 10. Expand carefully and then simplify. How do we simplify this with the fraction? Just in case you're worried. Well, you look at the 3 and the 5 as a denominator, make the denominator common, right? So we're going to make the denominator 15. So if you do that, you will actually find that it simplifies to 8x over 15. And the numerical here, they end up as 8 over here, right? So I plus 10 and minus 2 this way. Okay, so finally, we divide by 8 times 15. We realize that x is actually equals to 15. Okay, now, once we have x, let's not forget to find our y. So continuing, substituting x equals to 15 into equation 3. Again, we choose equation 3 because y is already the subject, right? So y equals to negative 15 over 5 minus 2, which gives us y equals to negative 5. Finally, write the final statement. Okay, it's a good habit to always do that. Therefore, x equals to 15, y equals to negative 5. And that is question 9a for you. Okay, now moving on to the last question of this particular assignment that I gave you, which is question 10, right? Question 10, the situation is this. They tell us that if x equals to 3 and y equals to negative 1 is a solution. Okay, means the question tells us what is the solution. Okay, then they give us a pair of simultaneous equation, and then we are supposed to find the unknown p and q. So what does this mean, right? Remember what is the meaning of equation? Equation, right, is a mathematical statement that is true for certain solutions of the unknown. So in this case, since the solution already was given to us, if we substitute it into the equation, it should work, right? Because it is supposed to make the statement true. So we're going to do exactly that, right? So over here, the first equation that we have in our question is 3px plus qy equals to 11. So we are just going to substitute um, the x with 3 and y with negative 1 because it is a solution that's given to us. Okay, and we end up with this, right? 3p times 3 over here plus q times negative 1 over here equals to 11. Simplifying it, we have 9p minus q equals to 11. So let's call this equation 1. Why not, right? And for the next equation, we are going to repeat the process. Replace the x with 3 and replace the y with negative 1. So we have negative q times 3 over here plus 5 times negative 1 equals to p over here. Simplifying this, we will have p equals to negative 3q minus 5. So what happened here is that the P is already the subject. So since P is already the subject in this form, it is quite straightforward and intuitive to just apply our substitution method, right? So we're going to substitute equation 2 into 1. So let's look at equation 1, 9p minus q equals to 11. So 9p, but instead of p, we get an expression from equation 2 minus q equals to 11. Expand the bracket carefully. We have this negative 27q minus 45 minus q equals to 11. Simplify some more, we have 28q equals to negative 56. That gives us q equals to negative 2. So since we need to find all the unknowns after we find q, we need to substitute it back into one of the suitable equation to get our value of p, right? So in this case, we're going to substitute into equation 2 because as mentioned many times, the p is already the subject in this case, right? So substitute q equals to negative 2 into equation 2, p equals to negative 3, q, replace the q in negative 2 minus 5, that works out to p equals to 1. So our final solution for this particular question is p equals to 1, q equals to negative 2, right? So I hope you have done well for this assignment. If not, complete your corrections and, well, learn from your corrections. Okay? All the best. Have a nice day.